Folks, I got a little data for us here. We're going to talk about the corner now, Continuous Y Discrete X. This is where your t-tests, your anovas, I'm going to box plot, things like that occur. We discussed regression the last time. That was a continuous Y, continuous, clarify that, continuous X. Okay? So, there's some steps before you just jump to hypothesis test. For example, the two-sample T test says, in this example, I have two breeds of cows in my dairy farm, brown cows and the white cows with the black spots, which are called Holsteins, okay? And I want to know, I've got some purchasing coming up for some new cows. I'm wondering, if I can just go by price, meaning are the cows' average production of milk the same? Okay, so every day when I got the total for the brown cows, this is Monday, Tuesday, Wednesday, Thursday, I also got the total for the Holsteins, okay? Now, most people just want to go to the two-sample T, and we want to say that our null hypothesis is the average production is equal, and our alternative hypothesis is average production is not equal. At GE, we just had a few things we would do first before jumping to the hypothesis test with this type of data. Number one, check normality. The Anderson-Darling test, Excel, if you do Excel add-ins, they have it. Minitab has it. Every stat software has it. What you're trying to do is you're trying to see if the averages are a good indicator of performance. So, for example, in this example, my brown cattle give me an average of, I don't know, what do you think? 83 gallons a day. For the sake of the argument, my Holsteins also give me around that, 85 gallons a day. So right now, I would say we're going to get a p-value greater than 0.05 when we do the two-sample t-test. It's simply going to compare the averages, and we would go pick a cow based on price. However, doing the normality test, you see here that the Holstein cattle do not have a normal distribution. Most cattle produce over here at 75, okay? But because maybe one cow was able to crank out, 110 or something, that cow has dragged off the average, and we made a wrong decision. So you want to check normality first because you want to account for that. In this example, a two-sample t-test can also be done with the median, which is a two-sample Wilcoxon, for example. That's one of the tests that would do that. All right, one sample Wilcoxon, two sample. And again, that example would be the medians are equal or the medians are not equal, okay? The second thing you want to do is check stability. If this is in time order, which in this example it is, it's the daily production by cow, you can look for stability on a control chart or a run chart. And again, another example of why you want to do that. Cow B has very stable production. However, the average looks the same for the Holsteins, the white cows with the black spots. However, look at the variation in this data. So statistics would have told you they're the same, but when you look at the graphs, I think it looks more better to go for the brown cow. How now, brown cow? I didn't even know I was going to be able to say that. So then step 3, if you feel comfortable with that, you can compare averages. And basically, what you're doing is you're trying to say, does this group have the same average as that group? All right? Or does this group have the same median as that group? Okay, so that's the comparison of centering. And then finally, step 4, you want to compare variation. All right? And unfortunately, Six Sigma is incorrectly defined based on what we were doing in the 90s as a tool to reduce variation. I haven't done a variation reduction project in years. I have done hundreds of projects on how to solve a problem, and very rarely has standard deviation being too high been a problem statement. It does occur, but that just shows you that Lean Six Sigma is not about variation reduction, okay? Could have been in the 90s, but this is 2020. In this example, we're trying to say, is the length or the spread the same? Now we know in this example it's not going to be, maybe we run a box plot and we see that the brown have a very consistent daily production And we would see in my made-up example that the Holstein cattle, white with black spots, have more variation. From a planning standpoint, I'd rather have a consistent daily production than an all-over daily production, because I'm also not going to be able to forecast. It's one of the greatest disconnects in business. Businesses talk averages. On average, you'll receive your part in 15 minutes. Customers feel variation. Hard to draw a histogram on the side. Customers feel all this. Last time I got it in 15 minutes, and then it took 60 minutes. Okay? But those are the basic steps for Continuous Y Discrete X. And of course, if you have 3 or more X's, it's going to be the ANOVA, and it's going to be under here the moods medium. Now these are the ones I use. I'm sure somebody could recommend something else. That's fine. There's also lots of different reasons why you might use one. Even the Navy has a tool called General Manova. Get it? General Manova board. I'm the king of bad jokes. I've been teaching long enough and beat up by HR more than I can say, so it's nothing but bad jokes from me. All right, so there you go. Continuous Y Discrete X.